Okay, so watch. When it becomes, then it is obvious that in upper bound only, in case of ascending order, the 39 should be present, but 39 is not present. It goes on until or unless big should is greater than end. That time it come to a conclusion that 39 does not exist in the array. This is the mathematics. If I go in n, then in second do exit control infinite loop, this is the descending order part. The same here I have done as it is, means when array mid value is greater than num, then end equals to mid minus 1, means the num value should be in the lower bound, means the number which is smaller than the mid value should be in lower bound, else if the number is greater, then the from that middle value it is in upper bound. That same logic I have done in descending order also. Now watch, 25 is present but it can't search, but 25, this 25 will be checked in this upper bound only, it will not go for that lower bound. That is the case. Watch, 25 does not exist, but yes, it exists. Now if I press, then enter. But if I make a single change, what I have already explained in case of this, just here big equals to mid plus 1, end is equal to mid minus 1, just that same change. Now it can do it. That change I have explained, but why it is, how it is running, I have to check. Suppose 1 I have to search, it has searched, no. Now suppose 25 I want to search. Okay, we will see this problem, that issue what is created. Okay, we will go for this problem afterwards. At first let's explain this part, how it is working. Okay, array 1, it is in ascending order. Suppose include stdio.h starting from our header file, then array declaration array 1, we will work with array 1 only. This is the procedure where it is working, we will see in there also, in the running code also. These are the explanations. Then it displays the size of an array. Size of array means, suppose one variable declaration is 4 byte in my PC, in different PC is different. 4 byte, if for one variable value declared is 4 byte, then 11 elements in an array I have allocated, I have stored. Then 4 into 11 bytes are there, 44. Then the number of elements is 44 by 4. This is the size of the elements. That's I have just displayed in the console. Then variable declarations, then variable declarations, character variable declaration, then displaying the array one by one. Now our main code starts from here. This is the formula, beginning plus ending by 2. This is the formula. Let's starting from 0 index. Beginning starts from 0 index and goes up to n minus 1, means size number of elements minus 1, 0 to 10. If I have 11 elements, 10 elements means 0 to 9. Now the found flag I have initialized inside this exit control do while loop. Exit control do while loop. Okay, enter the number that has to be searched. Okay, now this is I have given as insert input. That criteria you have remembered while running the code. Beginning should not be greater than equals to ending. Beginning should not be greater than equals to ending. Less than equal. So it is in if If it is in lower bound, then it will go for checking and checking for lower bound only, and when big becomes equals greater than end, then it will eh, say that it does not exist if it is exist in upper bound also. So sorting is necessary, and vice versa for upper bound too. So if so, mid should be this big plus n by 2. Okay, it should be big plus n by 2. And the search is done at index percent d equals to percent d, means first mid the value element is stored what. Okay, if array mid is not equals to num, then match not found, that I have shown. And if array equals to num it got, then percent is present in the array at position here at this mid index. Found flag become equals to 1. Very simple, found flag will become equals to 1. Very simple. So why don't I declare initialize these things here, it will be much better. Okay, otherwise complexity will be increased, time complexity. Next, and then this is another if statement. If array, then at this position flag become reinitialized equals to 1, and if it got, then it break the loop. Else if array mid is greater than num, that I have discussed, means the num value is very simple, means the num value, if it is less than the mid value, means less than 14, if 14 is the mid value, means in the mid value suppose 11 elements are there, 0 to 10, the mid index is 5, and if their element is greater than the num value which I want to search, then it is in lower bound. For checking lower bound, it will reinitialize end equals to mid minus 1 in case of ascending order. Else if the num value is greater than, then it is in upper bound, then beginning is equal to mid plus 1, and again this formula will be implemented. Then end equals to mid minus 1, new end plus same big by 2 when the num value is in lower bound, and when the num value is upper bound, then new big plus same end by 2. That way it will search, and it goes on and goes on until or unless big is greater than end. And if it greater than end, then there is no chance in either in lower bound or in upper bound that the element present. So that's why sorted array is very much important. Unsorted array it cannot find. That's it. And then printing for the after the match found or not, after the match not found, it will print, means before exiting the loop. In each case of match not found, it will print the big is this and the end is this. Big is this, end is this, means if it is this, then the new big, if element is in upper bound, then new big is equal to will be given here, and the same end will be there, and vice versa. Okay, and when in each searching, when big becomes greater than n and found is equal to as initialized as it is, as resetted as it is, then that does not exit, and this is exit control infinite loop. Okay, up to this much. Thank you.